This is my second tree response problem, and the question is, the rate at which people enter an auditorium for a rock concert is modeled by the function r given by r of t equals 1380t squared minus 675t to the third for 0 to 2 hours. R of t is measured in people per hour. No one is in the auditorium at time t equals 0 when the doors open. The doors close and the concert begins at time t equals 2. First question is A. How many people are in the auditorium when the concert begins? So that would be a total amount problem. And because this is a rate, to find the total amount, we would just take the integral of the specified, the integral of the specified integral. So the interval is 0 to 2, and it'll be r of t dt, which equals 1380 t squared minus 675 t to the third, which equals approximately 980 people. I ran out of space here, but 980 people. Now, part B is find the time when the rate at which people enter the auditorium is a maximum. Justify your answer. Now, part B. Now, to find a maximum, we first have to find the derivative of r of t. And then from there, we're going to find the critical numbers, or when t equals 0. First, find the derivative. So, derivative of r of t equal 2760 t, because you bring the 2 down and then subtract the 1 from the power of t, which was 2. So 2760 t minus 2025 t squared. And what we did for that is times 675 by 3 and then subtracted 1 from 3. So we have r derivative of t equal 2760t minus 2025t squared, which is going to equal that to 0. And we're going to take out 15t actually. Factor that out, which leaves us 15t times 184 minus 135t. And then split that up. We go 15t equals 0. We have 184 minus 135t equals 0. Right over here, you can cancel 15 out. T equals 0. Over here, subtract 184, divide by 135, and then you get t equals, or actually, no, forget that. Add 135 over here, and divide 135 over 84, so you get a positive number. So it's going to be t equals 184 over 135. Now I gotta look at the endpoints when you have your critical numbers. So we got R0, which equals 0, and R2, which equals 120. Now, and you have R of 184 over 135, which equals 854.53. 854.53. Now, the time when the time when the rate of people entering the auditorium is a max is at R equals, or R 184 over 135. So when T equals approximately 1.36296. So let me write this down. Time rate is a rate of people entering is a max is at time T equals 1.36296, and 1.3296 is 184 over 135. So this approximately equals that. Now, it's a max because R of 1.36296 is greater. Let me write that down. R of 0.3926 is greater than R of 0 and R of 2, which are the endpoints. R of 0 and R of 2. So R of 1.329 or 926, 2926, 336, 296 is greater than the endpoints, which are R of 0 and R of 2, which equal respectively 0 and 120. So it's greater than that, and 1.392, 1.36, 1.36296 is a critical number. So with it being a critical number and greater than the two endpoints, it is a max, and it fits the criteria for being a max. Question C says the total wait time for all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium, ending when the concert begins. The function models the total wait time for all people who enter the auditorium before time t. The derivative of W is given by WT equals 2 minus T R of T. Find W2 minus W1, the total wait time for those who enter the auditorium after time T equals 1. So for this, we're going to start by finding the total wait time. As you know, like before, for totals of any rate, we can take the integral. So take the integral from 1 to 2, W derivative of WT. Now, this WT is going to equal integral of 1 to 2, 2 minus T, and we have R of T, right? So it's going to be 1380 T squared minus 675 T to the third dt, which then equals 387.5 minutes. Essentially, we just found the integral of the rate, which is going to be the total amount, 387.5 minutes of total wait time for people who entered the auditorium after time t equals 1. Now, for the last part of this problem, D, we have, on average, how long does a person wait in the auditorium for the concert to begin? Consider all people who enter the auditorium after the doors open and use the model for total wait time from part C. Basically, what we're going to do here is this. So we're going to go and use that model, but we're going to take a spin on it, and it's going to be basically 1 over the total amount of people in there, and it's going to be similar to an average value formula, but not average value, because actually we're just taking 1 over the total amount of people that was in there, and then we're going to times it by the function w at time t2. And really this is really meant to be 1 over b minus a, b being 980 and a being 0, from being total amount of people in there and then the least amount of people in there. So this is going to equal 1 over 980 times the integral, because that's what w2 is. It's going to be the integral from 0 to 2 minus t, and it's going to be RT. It's going to be 1380t squared minus 675t to the third dt, which equals 0.77557. This is approximately 0.776 hours of wait time on average. This is wait time on average. So that is the last problem. Just going to recap all the questions. We have A is total amount, which is 980 people. B, which is the time and the max rate, find the rate when the rate was a maximum, and that was at time 1.36296. Wanted to find the total wait time for all people in the auditoriums, part C, which was 387.5 minutes, and then we wanted to find the average wait time, which was 0.776 hours. Fix that 7. Thank you.